Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter real numbers. Now let's go for continuing this. As we know that in this chapter already we have finished two exercises. One is exercise number 1.1, which was completely related to Euclid's division algorithm, and second one, that is exercise number 1.2. This was related to fundamental theorem of arithmetic, right? Both were over, and now we are going to focus some of the additional problems, only few simple additional problems on second exercise. Got it? And before that, just we shall recall 2 to 3 important points. We have already learned that how to find out the HCF and LCM of two given positive integers by FTA, right? Then what is the relationship between the given positive numbers A and B and their HCF and LCM? Yes, you are right. It is HCF into LCM is equal to A into B. That is the product of two numbers, right? Then when you know any of these three terms, you can go for finding the fourth term. Next, you will find out the HCF and LCM of the given positive integers. Then what is the relationship between HCF and LCM? We know that HCF is a factor of LCM. And another point, LCM is always the multiple of HCF. One more important point, what is the HCF of prime numbers? Yes, you are right, it is 1. What about their LCM? That is LCM of prime numbers. It is the product of the numbers. Clear? Then here I write A and B are prime numbers. Their HCF is 1. If A and B are prime numbers, their LCM is the product of those numbers. That is A into B. Then even we have got information about co-primes. A pair of numbers whose HCF is 1. If it is so, what is the LCM of co-primes? Again same, the product of the numbers, right? So now, with this information, let's go for continuing today's class. As I said, in today's class, we are going to solve some of the additional problems with respect to exercise number 1.2. Here I have taken two simple statements. Please go through them. The first one, nobody should go for copying anything. Understand the statement and listen my explanation. Then afterwards I'll give you the time. You can make use of that time for copying the entire question with the solution. Observe. On a morning walk, 3 persons step off together and their steps measure 40 centimeter, 42 centimeter and 45 centimeter respectively. What is the main distance each should walk so that each can cover the same distance in complete steps? Clear? Or what is the maximum distance each should walk? You can also take like that, main or maximum. Listen, here how many persons are given? 3 persons. And what is the length of their steps? It is 40 centimeter. Just look here. Here a person with his steps. The distance from here to here, it is 40 centimeter. It is the length of the step of first person. Similarly, second person 42, third person 45. Then all they start walking together. Then what is the distance, maximum distance each has to travel such that they have to finish that distance in exact number of steps? One can finish after 10 steps, another one can finish after 12 steps, or one more can finish after 9 steps, but there must be exact numbers. Clear? It should not be 9 and half, 3 and half, 12 and half, 10 and half like that. Please do remember. Then every time, as if they have to cover that distance, every time they should go on increasing the number of steps, right? Then it is being multiplied. See the first person 40 centimeter, in the next step he covers total 80 centimeter, next 120 centimeter, like that. Here the numbers are being multiplied, right? Then could you tell whether it belongs to HCF or LCM? Yes, as it belongs to multiples, hence we can say that this problem comes under LCM. Clear? Okay, now let's go for solving this. Here, let me write the data. So, length of the step of first person. Here I'll write. Length of the step of first person. How much? It is 40 centimeter. Similarly, length of the step of second person. How much it is? It is 42 centimeter. And similarly, one more person, third person, length of the step of third person. How much it is? You can observe that. It is 45 centimeter. Then what you are going to find out? The maximum distance each should cover. So here I will write maximum distance to be covered by each. That is going to be found out. Calculation. Just we have come to know this statement belongs to LCM, right? Then here there is no particular method to solve this one. Particular method has not been asked. So whatever, you may go for division method or else FTA method, whichever you like. Here I write maximum distance to be covered by each is LCM of, let me write those three numbers, 40 centimeter, then 45 centimeter, 42 centimeter, then 45 centimeter. Clear? Let us go for finding. Here I write. You may go for taking by FTA method. 40 centimeter is there. Here 2 20s are, 2 10s are, 2 5s. Next 42 centimeter is there. This can be written as 2 21s are, 3 7s. 45 is there. You may go for writing it as 5 9s are 45, then 3 3s are. I hope that you have understood. Now let me go for writing the prime factorization. 40 is equal to 2 is repeated by 3 times, 2 cube into 5. Then 42, this is equal to 2 into 3 into 7. Then 45, which is equal to 3 is 2 times and 5 is 1 time. Here only just I go for writing. Okay. You are going to find out LCM. LCM is equal to, you will write all the factors involved. What are the factors? 2, then 3, 5, 7. 2 into 3 into 5 into 7. Then write whether we should take highest power or lowest power of each prime factor. Yes, it is highest power. Then what is the highest power of 2? It is 3. Highest power of 3, 2 is there, 1 is there, 2. Highest power of 5, 1 is there. Highest power of 7, 1 is there. It is equal to, what is 2 cube? 2 cube is 8. 3 square, 9. Then 5 raised to the power 1, 5. 7 raised to the power 1, 7. 5 7s are 35. It is equal to, then you go for multiplying these. 35 8s are, 35 2s are 70, 74s are 280. 280 into 9. Did you understand? See that 8 5s are 40, 4 will remain, 8 3s are 24 plus 4 28. You can go for like that also. then into 9, it is equal to 9 zeros are 0, 9 eights are 72, 7, 9 twos are 18, 18 plus 7, 25, 2520 centimeter. This is the distance to be covered. You can also go for expressing that in meter as well. See, this much centimeter. To express that in meter, it should be divided by 100 because 1 meter equal to 100 centimeter. Then it will be 25.2 meter. Hope that you all have understood this one. Yes. Can you write conclusion? Yes, you are able. What the conclusion can be written? Yes. Conclusion is, therefore, the maximum distance each should walk so that each can cover the same distance in complete steps or exact number of steps is 25.2 meter. Okay. Now, observe it. Here, this can also be solved in another method. Here, as I said earlier, they have not asked you to solve it from particular method. So, if you know other method, you can also go for finding that. This is the lower class method. You can go for finding the LCM of 40, 42 and 45 in this way. Observe it. Here all are multiples of 2, particularly these two, or else you can go for even 5 also. 5 8s are 40. 5, it is not divisible, keep that 42 as it is. 5 9s are 45. Now see that these two are the multiples of 2. Start from 2. 2 4s are 8. 2 21s are. Then 9 as it is. Now these two are the multiples of 3. 3, keep that 4 as it is. 3 7s are 3 3s are. Now see that LCM is equal to 5 into 2 into 3 into 4 into 7 into 3. Just go for multiply. 5 2s are 10. 10 3s are 30. 34s are. It is 120 into 7 3s are 21. Now multiply. 0. 21 2s are 42. 4. 21 ones are 21 plus 4. 25. 2520. See that? We have got same. Got it? Okay. Now, don't go for copying. Afterwards, you can go for writing. I'll give you time. Just observe second one. Second one is the dimension of a room is 700 centimeter, 600 centimeter into 500 centimeter. Dimensions means that the length, breadth and height of the room. They are given. Length is 700 centimeter, breadth is 600 centimeter and height is 500 centimeter. What is the maximum length of the tape required to measure the length, breadth and height in exact number of times? So what you will go for? First I'll write data, then we shall go for discussing about this situation. They have given the dimensions of a room. What is the length? Length is 700 centimeter. They could have given even in meter also. See that? 7 meter. Breadth 600 centimeter. Height, it is 500 centimeter. What is the maximum length of the tape, measurement tape required to measure length, breadth and height of a room in exact number of times? Means if you go for, suppose, think that this is the length of the room. If you go for taking the tape, say, on measuring, it should complete in exact number of times. Not, it should come half like this. Clear up? Then what is the maximum length of that tape is to be found out. Here, just for the sake of understanding I am drawing. It is a room. This is length, this is breadth, and this height. Already we have written that. Then whether it belongs to HCF or LCF. Just to think over it. The length, maximum length of the tape required. Will you go for taking the length of the tape as 700 centimeter, 600 centimeter, 500? No. Just that it should have some length. And using the tape, when you go for measuring the length, breadth and height of a room, it should come in exact number of times. Hence, the least you are going to find out the maximum length of the tape. That is nothing but the least number which divides all these numbers exactly. Now you tell whether it belongs to HCF or LCM. Yes, you are right. It is HCF. Okay. Here I'll write maximum length of tape. That is equal to question mark. Here I'll write length of tape is equal to HCF of those numbers. What are? 700 centimeter, then 600 centimeter and 500 centimeter. You are going to find out the HCF. By which method? You may go for either Euclid's division lemma or fundamental theorem of arithmetic. Any one can be followed because particular method has not been asked. So I go for following FTA method because we find it easier. Here 700 is there, 700. Now find out the factorization. 700 then 5 2s are 0s. Then again 5 4s, 2 2s. Next another one 600. 600. You have to use scale and pencil to draw the lines. Do remember. Now this is again 5 because we want prime numbers. 5 1s are 5. 1 will remain 10. 2s are 0s. Then again from 5 2s are 10. 2 will remain 20. 4s. Now 2 1s are 2s. 2 6s. Then 2 3s. Clear? Next one more. What is that? 500. 500. Which number can be taken? 5. 5 hundreds, then 5 2s are 0s, 5 4s are 2 2s. Now let us go for writing the prime factorization of each number. Here I will write 700 is equal to 2 is repeated by how many times? 2 times, 2 square into 5 2 times, 7 1 time. Next 600, it is equal to, see that 2 is repeated by 3 times, 3 1 time, 5 2 times. Next 500, it is 2 square into 5 cube. Clear? Next, let us go for finding HCF. What is the HCF? Here are HCF is the product of least power of each common prime factors. So just go for identifying the common factor. 2 is in, it is a factor of 700, it is a factor of 600, it is a factor of 500. 2 is there. And even 5 is there. Here I'll write 2 into 5. You have to write their least power. What is the least power of 2? Here 2 is there, 3 is there, here 2. Then what is the least power of 5? 2 is there, 3. So 2. What is 2 square? 4. 5 square? 5 5s are 25. 25 4s are 100. Clear? HCF is 100. Here LCM that we have got was this. Okay. Now you can go for writing the conclusion. Conclusion. What you will write? The maximum length of the tape required to measure the dimensions of a room in exact number of times is 100 centimeter. Clear? If 100 centimeter tape is taken or scale is taken, then the length can be measured 7 times. 700 is there. 700 by 100, 7 times. Here breadth 6 times and height 5 times. Clear? So now you will go for writing the conclusion yourself. So even for first problem also. Can you write it? Yes. Now by pausing the video, you should go for copy from here. See the statement, data, calculation, then prime factorization, LCM, at last conclusion. Next, other method. If you want, you can go for writing this. After that, you can go for second one. Copy that second one, then data. Again, this point is very important because you are going to tell that, you are going to give the information that the concept which we are going to use to solve the problem. So then after that, again from prime factorization, you will find out the HCF. At last you will write conclusion. Yes, please copy this. Observe, we have one more statement. This is also very nice. Already this problem, this type problem was solved in that exercise only. I think you might have remembered a problem regarding two persons, two boys. One is Rohit and another one is Harshit, right? Same type, but there the speeds with which they were moving were not given, but here they are given. Once we shall move through the given statement. It is a circular field has a circumference of 360 meter. They are given a circular field and its circumference, that is the distance around a circle, it is 360 meter. Two cyclists, one is Rushabh and another one is Abbas, start together and cycle at speeds 6 meter per second and 9 meter per second respectively. That means Rushabh will start cycling with a speed of 6 meter per second and Abbas will start cycling with a speed of 9 meter per second around the circular field. As in that they start moving from this point. Next, after how many hours will they meet again at starting point? Got it? If they keep moving in this circular field, around this circular field, then if they want to meet again, they should keep on moving continuously, right? Here it goes on being multiplied. Hence, it belongs to HCF or LCM? LCM, right? Okay, this is the statement related to LCM. But how to find out that? Here they have asked after how many hours will they meet again at starting point. If you want to find out that, you must know what is the time taken by each of these two cyclists to complete one round. Let's go for finding that. Before that, just let me write data. A circular field has circumference 360 meter. So we can write circumference of field or perimeter. Circumference of the field, that is equal to 360 meter. There are two cyclists, Rushabh and Abbas, both are cycling with a different speed. So Rushabh's speed, Rushabh is cycling with a speed of how much? It is equal to 6 meter per second. That means in every second he is covering a distance of 6 meter. Next, another one is Abbas. Abbas speed, it is equal to 9 meter per second. Then around the circular field, after how many hours will they meet again at starting point? Let us discuss about that later. Here, but I'll write in data as after time after which both meet again at the same point, it is to be found. Calculation. First we must know what is the time taken by each cyclist to complete one round around that circular field. How do you find out that? Here we know that the distance they have to move, right? And their speed is given. Could you tell which physical quantity is related to distance and speed? Obviously, it is time. Then, because we have a formula to find out speed. Speed is equal to distance by time. What about time? Time is equal to cross multiply d by v. I hope that you have understood. Now here on right, time taken by who? Rushabh to complete one round. That is equal to distance by speed. What is the distance he has to cover? It is 360 meter. And what is the speed with which he is moving? 6. Altogether, it can be written as 360 by 6. And when you are calculating, you have to consider the unit also. See that the distance around the field is 360 meter. Here, speed, meter per second. Meter is there. All are in SI unit. So, 1s are 6 are. So, it is 60 seconds. This much time will be taken by Rushabh. What about time taken by Abbas? Time taken by Abbas, again to complete one round. That is equal to 360. This is the distance to be covered by him. One round around a circular field, and he is moving with a speed of 9 meter per second. 1s are 4s are 40 seconds. It will take just 40 seconds to complete one round, and it takes 80 seconds to complete 2 rounds. Next 120 seconds to complete 3 rounds. Like that, it will go on multiplying. Then similarly here also 60, then 120, then it continues 180, 240, like that. So here, time after which they meet. What is that? It is LCM of 60 seconds and 40 seconds. Now let us go for finding the LCM. Here I'll write 60. Find out the factorization of 60. 2, 30s are 3, 10s are 2, 5s are. Next, 40 seconds, 40, 2, 20s are 2, 10s are 2, 5s are. Now let me write 60 is equal to 2 is repeated by 2 times, then 3 is repeated by 1 time, and 5 is repeated by 1 time. Next, 40, it is equal to 2 is repeated by 3 times, 5 is repeated by 1 time. We want LCM. LCM is equal to how much? First you go for taking all the factors. The factors that are involved are 2, 3 and 5. Then should we take highest power or lowest power? We have to take highest power. Highest power of each factor. 2 is 3. 3 is just 1. 5 is 1 only. Now what is 2 cube? 8. 8 5s are 40. 43s are 120. Clear? 120 means how many rounds Rushabh will complete? For one round it takes 60 seconds. and in 120 he completes 2 rounds. By the time he completes 2 rounds, what about Abbas? He takes just 40 seconds to complete 1 round. In 120 he completes 3 rounds. Understood? When Rushabh completes 2 rounds, Abbas completes 3 rounds. Then both will meet again at the same point. Clear? So we can LCM is equal to 120. That is 120 seconds. Therefore, conclusion can be written like this. Therefore, Rushabh. Therefore, time after which both meet again. Time after which both meet again is how much? 120 seconds. Got it? I hope that you have understood this one. Okay, these are the statement problems and still many are there. So after completing this chapter, we will go for taking some more different types of problems. And now before going to the next concept, we will move on to one more problem. This is very simple. It was asked in the examination as well. Dear students, you all know that there is a relationship between HCF and LCM of the given 2 positive integers. What is that relationship? Yes, HCF is the factor of LCM or LCM is the multiple of HCF. Right? Now the question was asked like this. Just I am remembering it. Now I am going to write the same. Can 2 numbers, the numbers are, here I am going to take, one is 27 and another one is 81. Can 2 numbers 27 and 81 be the HCF and LCM of given 2 positive integers? Understood? Very simple. Can these numbers, that is, can 21 and 81 be the HCF and LCM of the 2 numbers? We do not know what are those numbers. Their HCF and LCM are known. They are given HCF is 27 and LCM is 81. Is it possible to take these 2? Yes or no? If you want to say yes, you have to give justification. The question will be given like this. Justify. Just I told you, if you find out HCF and LCM of the 2 given positive integers, then we will come to know that HCF is a factor of LCM or LCM is a multiple of HCF. If you want to call 27 and 81 as the HCF and LCM, 27 should be factor of 81 or 81 is the multiple of 27. Let us check it out. What do you say? Your answer, yes or no. You can say that yes. Yes. What is that yes? 27 and 81 can be HCF and LCM of 2 numbers. But how? Justification. Here I'll write justification. Now let us go for dividing 81 by 27. Divide. Both are divisible by 3, right? 3 9s are, 3 2s are 6, then 2 will remain 21. 3 7s are 21. Now 27 by 9. 9 1s are 9, 3s are 21 1s are 27 1s are 27, 3s are 81. So 3 is a whole number. Therefore, 21 and 81 are the HCF and LCM of the given positive integers. Understood? If I go for taking another example, just only for discussion, let your attention be here. Suppose there are 2 numbers, we have found out their HCF and LCM, and I am going to write those numbers, HCF and LCM. HCF is 20 and LCM is 100. Is it possible to take 20 and 100 as the HCF and LCM? Yes. Why? Because 100 can be divided by 20 completely. I go for taking another one. 20 and 85. Is it possible? Is it possible to take 20 as HCF and 85 as LCM? Impossible. Why? See that when you go for dividing 85 by 20, 20 does not divide 85 completely. We will get the fraction. Hence, these two are not HCF and LCM, whereas these two are HCF and LCM of the given two positive integers. I hope that you have understood. So, these are the additional problems with respect to exercise number 1.2. Now, we are moving to the new concept. Before that, you have to pause the video and should copy the statement problems from here to here with conclusion. After that, copy this problems. Yes, copy it. Yes, now we are moving to the next part of this chapter. Just go through the heading here. Revisiting irrational numbers. We are already familiar with irrational numbers. What are irrational numbers? A number which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Right? That's the definition. An example for irrational numbers, we can go for giving like this: root 2, root 3, root 5, root 6, root 7, root 8, 2 plus root 3, and then 2 minus root 3, root 7 by 2, 2 root 7 by 5. Like that, so many examples can be given. These are the irrational numbers. They cannot be expressed in the form of P by Q. You can express root 2 in the form of P by Q as root 2 by 1, but it cannot be expressed in the form of P by Q under the condition P and Q are integers and Q is not equal to 0. Then do you say that root 2 and 1 are integers? No. Root 2 is not an integer, but 1 is an integer. So, these are the examples for irrational numbers. And even we have defined irrational numbers in terms of decimals. Just I am going to write one decimal number. Look here. 2.10, 100, 1000, and so on. Let me take one more. 13.110, 1100, 3 times 0, and so on. See that, is there any end for this? No end. It is non-terminating. Whether any repeating block is there? No. So it is non-terminating, non-recurring. A number whose decimal expansion is non-terminating, non-recurring. A number whose decimal expansion is non-terminating, non-recurring is called an irrational number. Clear up? Now, in this part, you are going to prove that these numbers are irrationals, which you have already learned in 8th standard by a method called division. And this year you are going to learn one method. So, before going to the method from which we are going to prove these as irrationals, we have to know two important points. Now let me go for introducing both of them. Just look here. Here I am going to write some numbers. You have to tell what are these. 2, 3, 5. What numbers are these? These are all prime numbers, right? Then I go for taking 16. Whether 2 divides 16? Yes, because 2 8s are 16. Then 16 can be written as 4 square. 4 square is 16. If it is so, if 2 divides 4 square, does it divide 4? Yes, of course. See, 2 2s are 4. Similarly, here also I can go for taking any numbers like 81. 81 is nothing but 9 square. If 3 is a prime number and this prime number divides 9 square. If it divides 9 square, it should also divide 9. Clear? This is one important point. But this is going to be proved logically. Hence, we have a theorem. Theorem 1.3. A statement which can be proved logically is called a theorem. A theorem related to this has been given here. Look here. Prove that let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Clear? Actually, the question should be like this. Let P be a prime number. If P divides A square, then prove that. What we have to prove? P divides A. Got it? But condition is given where A is a positive integer. So to prove this theorem, we have certain particular steps, definite steps, series of steps are there. Let us go for them. First, I write the given information. What has been given? Look here. They won't have given. You can go for assuming P as prime number. Here I'll write P is a prime number. One thing. Next, what is another thing? P divides A square. They won't have given. P divides A square. Next, other than that, A is what? A is a positive integer. A is a positive integer. Then what you are going to prove? You are going to prove that P divides A. P divides A. This is going to be proved. How? As I said, as it is a theorem, it should be proved with the logical steps. Let's go for proof. I'll use the given statement. What it is? They are given P divides A square. P divides A square. It has been written from data. What does it mean? P divides A square. If 3 divides 10, what do you call? Sorry, here I'll write. If 2 divides 10 completely, what do you call 2? 2 is a factor of 10. If P divides A square, then can we write P is a factor of A square? Yes. P is a factor of A square. I call this statement as alpha. Understood? Okay. Now, here they have given A is a positive integer. Any positive integer, and it has prime factorization. Now I am going to write the prime factorization. Here, the prime factorization of A as follows. How do you write? Here I'll write A is equal to, see that, P1 into, not point, into P2 into P3 into P4, P5 and so on. I call it as up to PL. Got it? P1, P2, P3 and so on. They may be primes or may not be also. Next, I go for squaring on both sides because they are given P divides A square. Then squaring on both the sides. Then if I do so, I can write A whole square is equal to P1 into P2 into P3 and so on, PL whole square. Can it be written so? Yes. Now this is equal to, I'll write, see that, if A square is there, it can be written as A into A. Then B square is there, B into B. A, then Y cube is there, Y into y. In the same way, here as we have written P1, P2, P3 up to Pn whole square, can we write this as P1 into P2 into P3 into so on Pn into again P1 into P2 into P3 into so on Pn? Yes. Now look here. If it is so, if I write 6 is equal to 2 into 3, what do you say about 2 with respect to 6? Yes, 2 is a factor of 6. What do you call with 3 with respect to 6? 3 is a factor of 6. Then can I write this P1, P2, P3 and so on, they are all factors of a square? Yes, either this or this. Here, according to this statement, I can go for writing P1, P2, P3 and so on, and Pn are the factors of a square. Clear? Now I call this as beta. See that? P is the factor of a square and these are the factors of again a square. Then from alpha and beta, how do you go for writing? Got it? Just like you used to call equation 1, equation 2. I have written just not equation, statements. Alpha and beta. These are the Greek letters. Alpha, you come across many Greek letters. Alpha, beta, gamma, theta, zeta, delta, iota, like that. Many are there. In forthcoming classes also we will go for using some more. Just here observe. We have taken alpha and beta. According to alpha and beta, see that P is a factor of a square and these are the factors of a square. Hence, P should also be one of the factor among these, right? Alright. P is a factor among what? P1, P2, P3 and so on. Pn. Right? Now come to that point. Look here. P is one of the factor among these. And we all know that these are the factors of what? A. Right? Then can we say that P is a factor of what? A. Is it not? If it is so, then what we can, if P is a factor of A, then P divides A. If 2 is a factor of 10, 2 divides 10. So, therefore, P divides A. Hence it is proved. QED. Quod errata demonstrandum. That means, hence the statement is proved. Or else you can also write, hence the statement is proved. Clear? Dear students, one more thing. This is one point to be remembered. Another point. As I said, to prove some of the numbers like root 2, root 3, root 5, root 6 as irrationals, we go for using two methods. One method you had learnt in 8th standard. That method is called division method. Here we are going to follow one method. Let me tell you that method. See that in some cases we will have to take the reverse of the given statement. Like if the number root 2 is a irrational number. For proving this, we will go for taking its reverse statement as let, that is assumption, consider or assume root 2 be a rational number. Clear on? So this is the method in which our statement is a reverse of the given statement, and we call this method as contradictory method. This is the method from which we are going to prove those numbers as irrational. Contradictory method. What is contradictory method? The method in which our assumption is a reverse of the given statement. Whatever the statement will be there, we are going to take it's in the reverse order. So I'll write the definition. The method in which our assumption is reverse of the given statement. Reverse of the given statement is called contradictory method. The method in which our assumption is reverse of the given statement is called contradictory method. Now let us come to know how to prove these numbers as irrationals by contradictory method. So now you have to copy from here, revisiting irrational numbers. Then irrational number definition I have already given in two ways. A number which cannot be expressed in the form of p by q, where p and q are integers and q is not equal to 0. That definition. In terms of decimal, a number whose decimal expansion is non-terminating, non-recurring is called an irrational number. After writing the definition, then you go for taking these examples. After taking these examples, you will start writing from here. Theorem 1.3. If p divides a square, then p also divide a. Then after that, this is contradictory method. The method in which our assumption is reverse of the given statement. Okay? Yeah, please copy up to here. Yeah, dear students, now we are going to prove some of the numbers as irrationals by contradictory method. Repeatedly I have been telling, contradictory method means it is the method in which our assumption is reverse of the given statement. Then you just observe, what is the given statement? Prove that root 2 is irrational. Then what should be our assumption? Our assumption should be let root 2 be a rational number. Clear? Now let us go for proving this. This is one of the important type of problem. I am going to put double star mark for this. You have to practice it without fail, because more chances are there to give this in the examination. Here, don't copy that. Just keep observing. Prove that root 2 is an irrational number by contradictory method. Here I will go for proving it. Prove. By which method? By contradictory method or CMM. Contradictory method. According to this contradictory method, we have to assume what? Let root 2 be a rational number. And we all know that if it is a rational number, it should be expressed in the form of p by q, right? So here I will write root 2 is equal to p by q, where here I will take, as it is to be proved by logical method, I go for writing p and q are co-primes. Then what are co-primes? Pair of numbers whose HCF is 1, or two numbers having no common factors other than 1. They are called co-primes. And q should not be equal to 0. These are the two conditions. This is our assumption. We have assumed p and q are co-primes and q is not equal to 0. Now, if you want to prove root 2 is irrational number, you have to show that our assumption is wrong. Means p and q are not co-primes. How? Let us go for finding the factors. That is why I will go for taking squaring on both the sides. Then root 2 whole square is equal to p by q whole square. Square and root get cancelled. Alright, 2 which is equal to p square. You have to apply square to both the terms, numerator as well as denominator. P square by q square. And this can be written as 2q square equal to p square. Understood? On cross multiplying 2q square equal to p square. That means, can we say that 2 divides p square? If you do not know, just you can do one thing. Q square equal to p square by 2. Q is taken to the left hand side and 2 is taken to the denominator of right hand side. Then what does it mean? P square by 2. P square is divided by 2. It means 2 divides p square. We have already come to know from the theorem. If 2 divides p square, then 2 also divides p. Right? I am going to write the same. Here I will write 2 divides p square. I have written the meaning of this. 2 divides p square. If 2 divides p square, 2 also divides p. It is according to theorem. What is that? Theorem 1.3. Next, if 2 divides p, then can we say that 2 is a factor of p? Of course, right? Here I will write 2 is a factor of p. Call it as statement, I call this as statement 1. This as statement 2. Next, you are going to show that p and q are not co-primes. Already we have got one factor, hence now I am going 2 is a factor of p. Another one we have to show 2 is a factor of q. That is why I go for taking substitution for p. Let p equal to 2k. If it is root 2, take 2k. Root 3, take 3k. Root 5, take 5k. In place of k, any other letter can be taken except those a, p and q. 2k, then p square equal to 2k whole square. It will be 4k square. Clear? Call this as equation 3. Then substitute 3 in 1. Substitute 3 in 1. Then 1 becomes, see that q square is equal to p square. What is p square? 4k square by, this is 2. Now you can divide. 2 1s are 2, 2s are. 2k square equal to q square. I solve k square. K square equal to q square divided by 2. Now you tell me, what is the meaning of this? It means just like this. 2 divides q square. If 2 divides q square, then 2 also divides q. It is according to again theorem 1.3. If 2 divides q, 2 is a factor of q. See that? Here we have shown that 2 is a factor of p and this is 2 is a factor of q. I call this as statement 4. From 2 and 4 we can come to know that 2 is a factor of both p and q. Right? But here what we have assumed? P and q are co-primes. Now you tell them whether p and q are co-primes or not. Yes, they are not. Why? Because if they are co-primes, their HCF should be 1. But here 2 is there. Now we can write, here I am going to write from statements 2 and 4. From 2 and 4, P and Q are not co-primes. But what we have assumed? We have assumed that P and Q are co-primes, right? Then therefore, our assumption is, what do you say? Whether it is correct or incorrect? It is incorrect. Or it is false. Therefore, our assumption is wrong. Our assumption is wrong. Then what we have assumed? Root 2 be a rational number. If our assumption is wrong, then what it should be? Root 2 is irrational. See that root 2 is an irrational number. Here I write. Hence, root 2 is an irrational number. I hope that you all have understood. Again, I have been telling this one is very important in the examination point of view. More chances are there. Just once briefly I go for telling this. You are going to prove root 2 is an irrational number by a method called contradictory method. In this method, our assumption should be a reverse of the given statement. Given statement is root 2 is irrational. So we have assumed root 2, let it be a rational number. As it is rational number, it is in the form of P by Q, where P and Q are co-primes. Pair of numbers whose HCF is 1 and Q is not equal to 0. Then squaring on both the sides, you will get, see that square and root get cancelled, then you will get P square by Q square. Go for cross multiplying. Q square equal to P square by 2. It means 2 divides P square. Then 2 also divides P. It is according to the theorem just what we have proved. If 2 divides P, then 2 is a factor of P. I called it as second statement. Then we want factor of P. Hence, let us take substitution for P. P equal to 2k because we are proving root 2 is irrational. Then P square equal to 4k square. Then substitute, call it as statement 3, substitute 3 in 1. You will get Q square equal to 4k square by 2. 2 1s are, 2 2s are. Now Q square equal to 2k square, k square equal to Q square by 2. It means 2 divides Q square. If it is so, Q, 2 will also divide Q according to theorem 1.3. And if 2 divides Q, 2 is a factor of Q. Then observe, 2 is a factor of P, 2 is a factor of Q. From 2 and 4, you can say that P and Q are not co-primes. We have assumed they are co-primes. Therefore, our assumption is wrong. If it is wrong, this will also be wrong. Hence, root 2 is an irrational number. Clear up? So, please go for copying from there to here. Let's copy. Yes. I am going to explain same type of problem, but the number is changed. See that. Second one, prove that root 3 is an irrational number. Again, it should be proved by contradictory method. Just listen. Don't go for writing. Observe this carefully. According to contradictory method, our assumption should be a reverse of the given statement. What is the given statement? Root 3 is an irrational number. Then our assumption should be let root 3 be a rational number. If it is a rational number, it can be written, that is root 3 can be written in the form of P by Q, where P and Q are co-primes and Q is not equal to 0. Then go for squaring on both the sides. Then it will be root 3 whole square is 3. P by Q whole square, it is P square by Q square. Then go for cross multiplying. Q square equal to P square by 3. What is the meaning of this? It is 3 divides P square. If 3 divides P square, what you can write? 3 also divides P. On what basis? It is from theorem 1.3. Then if 3 divides P, what does it mean? It means that 3 is a factor of P. You may call this as statement 2. So you call this as statement 1 and this as statement 2. Next. Just we have come to know 3 is a factor of P. We want P, 3 is a factor of Q. Hence I go for taking substitution for P. What should be taken? P equal to whether 2k, 3k, 5k, 7k. It is 3k because we are proving root 3 is an irrational. So P equal to 3k. Then squaring on both the sides. P square equal to 3k whole square. Apply square to both. 3 square is 9. k whole square is k square. And you may call this as statement 2. Statement 3. Substitute 3 in 1. Substitute statement 3 in 1. Then you can write q square is equal to p square by 3. What is p square? 9. 9 k square by 3. Cancel. 1s are, 3s are. So q square equal to 3k square. Solve k square. K square equal to q square by 3. What does it mean? It means that 3 divides q square. If 3 divides q square, 3 also divides q. According to theorem 1.3. If 3 divides q, what do you say? 3 with respect to q. 3 is a factor of q. Factor of q. You may call it as statement 4. See that this is 2. This is 4. 3 is a factor of p. 3 is a factor of q. So from these two you can write 3 is a factor of both p and q. But here what we have assumed? P and q are co-primes. What should be its factor according to co-primes? Only 1. But here 3 is also there. Hence, do you say that p and q are co-primes? No. So here I write from 2 and 4, p and q are not co-primes. If they are not co-primes, therefore our assumption is wrong. Assumption is wrong. Then what should we write? You can write hence root 3 is irrational. Irrational. Proved. Clear? Okay. So you have to practice today's 2 problem as many times as possible till you be perfect. You go for practicing. And today also we have covered important problems, particularly statement problems on fundamental theorem of arithmetic and irrationality of numbers. Okay. So before concluding, again I am reminding you, whatever we have covered today, practice it today itself. Don't keep anything pending. And tomorrow also again I come with another interesting concept. With this, let us stop the class. Thank you.